Question 4 is about bonding, and it's a classic hydrogen bonding question at the start. So we've got to complete the diagram to show hydrogen bonding between two water molecules. And it does say include relevant dipoles and lone pairs, label the hydrogen bond. So get the dipoles on, so delta minus on the oxygen, delta plus on the hydrogen, and the same for the other molecule. Put your lone pairs in. And then the rule is the hydrogen bond must start at the lone pair, and then it goes to a neighbouring hydrogen. State and explain two anomalous or unusual properties of ice which are caused by hydrogen bonding. So I've highlighted ice because I'm sure a lot of students would go into autopilot and just talk about water. And you've got to be careful here, because if you mention, say, surface tension, that's not relevant because ice is a solid. And the other classic mistake would be to talk about boiling point. Ice melts before it boils. So I would be talking about melting point, certainly. You can see I've put that down as the second point there. And the other one I'm going to bring in is the density. So ice has a lower density than water. That's why ice floats on water. And so when ice forms its open lattice structure, the hydrogen bonds extend, they push the molecules of water further apart. That increases the volume of the water and or increases the volume of the structure, and but the mass doesn't change, so the density drops as a result. Ice has a higher melting point than expected because extra energy is needed to overcome these hydrogen bonds, which are relatively strong. Remember, you're not breaking these bonds when you melt something. It's the intermolecular forces. And the next part of the question, classic, nice, easy dot and cross diagram, CO2. I'm sure every AS chemistry student's got this in their notes. Silicon dioxide has the same structure and bonding as diamond. So as long as you know that diamond is giant covalent, there's your answer. Describe and explain the electrical conductivity of sodium oxide and sodium in their solid and molten states. So you can see I've just quickly scribbled up in there, and I would encourage you to do this in the exam. That's ionic. How do you know? Well, that's a metal, that's a non-metal, and they form ionic bonds with each other. So sodium oxide in the solid state, this is true for all ionic compounds. They can't conduct electricity because the ions aren't free to move. The number of times you see electrons in there and you can't give the mark. It's the ions that can't move, or you could say they're not mobile. However, when it's molten, it can conduct electricity because the ions are now mobile. I hope I've made that point. Sodium, however, sodium's a metal, so if you can imagine the metallic bonding diagram you would draw, you've got the delocalized electrons flying all over the place, moving about at will, and so sodium can conduct electricity when solid and when molten because it's got this metallic structure with its delocalized electrons which are free to move.